Hello everyone. In this video we are going to learn about exponents. This is a concept of class 8. So let's start by understanding the meaning of exponents. So exponent, in simple words, if I say, the meaning of exponent is power of a number. Power of a number. So that number, if I suppose that number is x and its power is n, then this n, which is power of the x, this is known as the exponent of this number. Here x it can be any real number, and n, it can be positive or negative integer. And this form, x to the power n, this form is known as exponential form. In exponential form, I have already explained you that this n is the power, or this is known as exponent, and this x, it is also known as base. This lower term x is also known as base. So now let's understand by taking the example in number form. See, format will be this only. Format will be x to the power n always. So I'll take any real number 2, which is this x now, and n I take any power 3. 2 to the power 3. Here in this example, 3 is the exponent. 3 is the exponent and 2 is base. So if I expand it, see, the meaning of exponent is that 2 to the power 3, it means 2 is getting multiplied 3 times, whatever the power is. So it's 2 into 2 into 2. This is exponential form and this is its expanded form. So this is the meaning of exponential form. If I take any other example, say 2 to the power, any number, will take different number, 5 to the power minus 6. The power, as I have already discussed, it can be positive also and it can be negative also. So 5 to the power minus 6 is again exponential form, where 5 is real number and minus 6 is negative integer. So now in order to calculate, you have understand the concept, you have understand the meaning, what is meant by exponential form. Now in order to calculate the sums, or in order to solve the problems related to exponent, there are few rules. So let's discuss about those rules. So the 3 rules in order to solve the problems are product rule, quotient rule and power rule. See, these rules, from the word itself we can understand this product. Product means something which is related with multiplication, as product means multiplication. So let us understand it. See, if we have any number, so same form we will take x, because this will be the standard form, then it can be any number. So x is any number and it is getting multiplied with another number, or with same number, not another, with same number, but the power of this first x is m and the power of this second x is n. See, the numbers are same, they are getting multiplied, only the powers are different. So according to this product rule, when the numbers are same, or this basis, when the bases are same and these numbers are getting multiplied, we have to add their power. So it will become x to the power m plus n. We'll take one example. Here I have 2 to the power 3, it is getting multiplied by 2 to the power 6. So then here we can see it is similar to this format. Bases are same, both of my bases are 2, same basis, and these numbers are getting multiplied. So when the bases are same and the numbers are getting multiplied, according to the product rule, we have to write that base one time and we have to add the powers, 3 plus 6. So it will become equals to 2 to the power 3 plus 6 is 9. So the exponential form of this is equals to this. So once again I will repeat, if the bases are same, see, the bases should be same and the numbers are getting multiplied. This thing is very important. If the bases are same and the numbers are getting multiplied, then we have to add the powers. So let's start, let's see the next rule now. This is quotient rule. So quotient rule, as we know, quotient is something which is related with division. So let's take example, its general form I'll tell you first. When I have x and again x, see the basis should be same. Whenever we are just doing product rule or quotient rule, in both of these rules the basis should be same. One of the x, its power is m and the other one has power n. So when the bases are same, see these rules we can only follow if the bases are same. So now x and x, they are same and they are getting divided. See, this is the sign of division. Then we have to subtract the powers. So it will be m minus n. The power of the numerator should be written first. So it should be m minus n. It should not be equal to x to the power n minus m. No. First is the power of numerator, then the power of denominator. So this also will take one example. I have a number 3 to the power 5 and same 3 to the power 2 I'll take. Here if I compare with this, it's same. See 3 and 3, bases are same and these numbers are getting divided. See, when bases are same and the numbers are getting divided, according to the quotient rule, we have to do subtraction of power. So it will be 5 minus 2. It should always be 5 minus 2, not 2 minus 5, because the power of the numerator should come first. So 3 minus 2 is 3 to the power 3. So when we solve this one, we will get this. Now let's proceed towards the power rule. Power rule is very simple. If I have any number x, we have its power x to the power n, and here we have bracket and the other power m. See, according to the power rule, when a number is in this form, see one number is already written with the power and then a bracket is there and another power is written, then both the powers, they will get multiplied. N into m, will finish off this bracket and n into m, both the powers will get multiplied. So x to the power nm. In number form also I'll take one example, 3 to the power 2 whole bracket 3. Now this, see, if I compare, we can see this x is equals to 3, this n is equals to 2 and this m is equals to 3. So it will become 3, these powers, both the powers have to be multiplied. So 2 into 3, so it will become 3 to the power 6. So we will use now these three rules and we'll solve the questions of exercise 2A. So before starting exercise, I will just explain you one small rule. See, I told you the power of the number, it can be negative also, positive and negative integers. So when the power is positive, easily we can solve. But when the power is negative, suppose its power is 2 to the power minus 2. When the power is negative, see, we can make this number power positive. This power, it can be changed to plus 2. One small thing we have to do reciprocal of this number. See, reciprocal of the number, reciprocal of the base, not the reciprocal of power. If I have x to the power minus 2, see, 2 base means it is 2 by 1. If I have any single number like 2, 3, 4, all these numbers, we can write it in this form, because if nothing is written, that we can write 1. So this 2 we can write in this form, and then of this number we can do reciprocal. It will become 1 by 2. See, 2 by 1, if we do reciprocal, reciprocal means numerator will be changed to denominator and denominator will be changed to numerator. So reciprocal, if we do this number, its power will be changed to opposite sign. Like if the power is negative, it will be changed to positive power. If it is positive, it will be changed to negative after doing reciprocal. So this is how we can make the power positive if the power is negative, by doing reciprocal of the base. Now let's start the question. See, all these rules you will understand in a better way when we do questions related to this. So the first question is evaluate. First part I am going to do now. In first part it's mentioned 3 to the power minus 1 into 9 to the power minus 1 bracket divided by 3 to the power minus 2. See, according to BODMAS also, we know first we have to solve bracket. See, always in exponential form you can be given so many terms and so many different signs can be there, plus, minus, division, multiplication all together. So you have to decide which one you should do first according to the BODMAS rule. So here see, B stands for bracket, so first one will solve the bracket. Then off means again multiplication, division, multiplication, addition and subtraction. So in this order we have to do. Now this one we will do first. 3 to the power minus 1 into 9 to the power minus 1. See, 9 in this chapter will coming across the terms which we have to change to exponential form. So 9 we will change to exponential form. 9 if I make the factor, so it will be 3 into 3 is 9 and 3 into 1 is 3. So 9 I can write it as 3 into 3. 3 into 3 means 2 times 3 is getting multiplied by itself. So if I have to write it in exponential form, it can be written as 3 to the power 2. So therefore 9 is equals to 3 to the power 2. 3 to the power 2. Just in place of 9 we have to write 3 to the power 2 and whole power minus 1. Now divided by 3 to the power minus 2. See, why we changed 9? Because according to the quotient rule or the product rule, whenever we have to solve the exponents, the basis should be same. So in order to make the basis same, I just changed 9 into its exponential form. Because with different bases we cannot solve the exponents. Now 3 to the power minus 1 into this, here if you just see it, this one 3 to the power 2 whole bracket 3 to the power minus 1. We have done power rule. So according to power rule, if a number has 2 powers, x to the power n and whole power m, so then these powers has to be multiplied. So this rule we will use here. Now 3 to the power 2 is 1 power and other power is minus 1. So both the powers we will multiply. 2 into minus 1. This will remain same, 3 to the power minus 2. Now 3 to the power minus 1 as it is we will write into 3 to the power 2 into minus 1. 2 into minus 1 when we multiply it will become minus 2. See, minus 1 into 2, 1 into 2, 2 and this minus sign as it is. So minus 2 divided by 3 to the power minus 2. Now here see, bases are same and the numbers are getting multiplied. So we will use product rule here. See, when bases are same and the numbers are getting multiplied, what we have to do? We have to add the powers n plus m. So same rule we will apply here. Base we will write only one time and powers we will add. See, minus 1 as it is along with the signs we have to take. Minus 1 plus this is minus 2. Minus 2. So 3 base only one time we have to take. Minus 1 plus minus 2. See, according to this rule, if the bases are same and the numbers are getting multiplied, so we have to add the power. So that's what I have done here. Divided by 3 to the power minus 2. Now we can just solve this. 3 to the power minus 1. See, these two signs are together, plus minus. So first two signs, whenever these are together we have to make it a single sign. So plus minus is minus 2. We'll close this bracket and divided by 3 to the power minus 2. Minus 1 plus minus is minus 2. Same thing I have written here, minus 1 minus 2. Now we will just add these numbers. See, both the negative integers we can just add. Minus minus is plus. So 1 plus 2 is 3 with the sign which is with the greater number. So with greater number we have minus sign, so it will be minus 3. So same way like we add simple integers, same way we have to add, same thing, minus minus plus and the sign which is with a greater number. So divided by 3 to the power minus 2. Now we can just remove this bracket because now we have fully solved it. Again here if you see bases are same, both the bases are 3 and these terms are getting, numbers are getting divided. So here we will apply quotient rule. When the bases are same and these are getting divided, we have to subtract the powers. So minus 3 minus minus 2. So don't get confused with the signs. Just take the number as it is. With this minus 3 is the power, with this minus 2 is the power. So take minus 3 and minus 2 as it is and we have to subtract it. So here also one minus sign will come because we have to subtract the powers. 3 minus 2, see again two signs together. Whenever two signs are together we have to make these two signs as one sign. So minus 3 minus minus, minus minus is plus. Minus 3 plus 2. So this we will just add like we do addition of integers. Plus minus is minus. So 3 minus 2 is 1 and the sign which is with the greater number. So minus sign is with greater number, so it will be 3 to the power minus 1. So the answer is 3 to the power minus 1 and I have already told you if you want to change this negative power into positive, you can do reciprocal of the base. So 3 means it is 3 by 1, so you can do just reciprocal of 3, so it will become 1 by 3 now positive power. So 1 you can write, if you don't want, no need to write. 1 time means that power is 1. So the evaluation of this is equals to 1 by 3. Now let's do the next part. So thus in second part it's given to us 3 to the power minus 1 into 4 to the power minus 1 bracket divided by 6 to the power minus 1. Here we can see, if we just see the bases, see the numbers are in their exponential form only because base is there and the power is there in all the three numbers. But if we see none of the bases are same, so how to solve? So if the bases are not same, then we cannot apply either product rule or quotient rule. So directly then we have to start and solve it. So here one rule I have told you in previous question, at last step we did that when the power is negative. I told you if the power is negative, if I have this n negative, x to the power minus n, so it will become 1 by x whole power n. See, reciprocal of the base we have to do and the power will be changed to positive. So same thing we will do here. So 3, if single number is there, always you can write it by 1. It will not make any difference. The number will remain same. Single number you can just write 1 in the denominator. So that it can be converted into fraction form, and fraction easily you can do its reciprocal. So reciprocal of this will be 1 by 3. Power, if 1 is the power, no need to write. If plus 1, no need to write, but minus 1 you have to write. So 1 by 3 into 1 by 4. See what I have done, I have just made these powers positive. Minus 1 I have changed to plus 1. See here it's plus 1 only. By doing the reciprocal of the given number. So reciprocal means I have changed numerator into denominator and denominator into numerator. So same here also we will do. So it will become 1 by 6. Simple multiplication we can do. So 1 into 1, 1, 3 into 4 is 12 divided by 1 by 6. Now if you see this, here we can see 1 by 2, 1 by 12 divided by 1 by 6. This is just similar to the division of rational numbers. So in division what we do? So in division we can just change this division sign into multiplication and do the reciprocal of the next number. So again it's reciprocal, if we do it will become 6. So simple, when we do division of two rational numbers, or division of two fractions, what we have to do, we have to change this division sign into multiplication, and the number which is after division, that number's reciprocal we have to do. Now simple multiplication, so we can do cancellation now. 6 into 1 is 6, 6 into 2 is 12. 1 into 1, 1, and 2 into 1, 2. So 1 by 2 is the answer. Now let's do the next part. In this question it's given to us 2 to the power minus 1 plus 3 to the power minus 1 whole power 3. See here, if we see the bracket, we see the numbers given to us, one is 2 and the other one is 3. Again bases are different, and moreover this sign is also of plus, that means they are neither getting divided nor getting multiplied. So this simple way we have to do like we have done the previous one. So what we can do here, we can first, because addition with negative powers we cannot do, so first step we have to change the powers into positive. So here you can write, as I have told you, if a number is written in this form, simple number 2, 3, 4, anything, then you can write its denominator 1. You can change it into fraction. Now in order to make power positive, you can do the reciprocal of this fraction. So 2 by 1, so reciprocal is 1 by 2. Minus 1 will be changed to plus 1, no need to write this plus sign as it is. Then 3 by 1 will be changed to 1 by 3. Power 1 or plus 1, no need to write that, whole power 3. Now this has become similar to addition of rational numbers. See, when we do addition of rational numbers, we know we just add these two numbers only if their denominator is same. Now the denominator is not same, so we have to take LCM. So let's take LCM of denominators. So 2 into 1, 2, 3 into 1, 3. So LCM of 2 and 3 is 6. So we have to make denominators same now equals to LCM. So 1 by 2 will just multiply, because we know 2 into 3 is 6. So with 3 we will multiply, because denominators we have to make equal to our LCM and they should be equal to each other also. Plus 1 by 3, 3 into 2 is 6. So with 2 will multiply both numerator and denominator. So both we have to multiply. 1 into 3, this simple multiplication we have to do. 1 into 3 is 3, 2 into 3 is 6, 1 into 2 is 2, 3 into 2, 6. Now we can see denominators are same, so we can add these numbers. 3 plus 2, 3 plus 2 is 5, 6 as it is we have to write. See, only one time, don't add denominators. Denominator only single time we write. We have already made these two similar, so we have done the multiplication part. Now we don't have to add this, only numerators we have to add. So 5 by 6 whole power cube. So whole power cube means we have to solve it. See, evaluate means we have to solve it. So power 3 means 5 by 6 into 5 by 6 into 5 by 6. The number getting multiplied by itself 3 times, because 3 is the power, 1, 2, 3. So 3 times we can multiply. 5 into 5 is 25, 25 is into 5 is 125. 6 into 6, 36, 36 into 6 is 206. So this is the 216, sorry, so this is the this one 125 by 216 is the evaluation of this one. See, we just have to, meaning of evaluate means we have to simplify the given thing and we have to solve it when there is no more power. So now let's do the next part. So the next part is fourth part, 3 to the power minus 1 divided by 4 to the power minus 1 whole bracket. See, I just want you to try this sum along with me and see whether you are able to apply the rules and solve it. Here here 3 to the power minus 1 and 4 to the power minus 1. See, although they are getting divided, but the bases are different. So we cannot solve it more, we cannot solve the exponent. So same thing, we have to make these powers positive and then we can solve it. So 3 we can write as 3 by 1 and 4 we can write as 4 by 1. Now in order to make the powers positive, we can do reciprocal of the bases. So here 3 by 1 will be changed to 1 by 3, power 1 no need to write, divided by 4 by 1 will be changed to 1 by 4, plus 1 no need to write, whole power 2. So 1 by 3 divided by 1 by 4. In first question also we did same thing. When two fractions they are getting multiplied, when two fractions they are getting divided, so what we can do, we can just change this division sign into multiplication and the number which is written after the division sign we have to do its reciprocal. So 1 by 4 again it will be changed to 4 by 1, whole power 2. See, first what we did, we made the powers positive by doing the reciprocal of the bases. Then this division sign, because division we cannot solve it directly, so this division sign we changed it to multiplication, and whenever we change division into multiplication we have to do the reciprocal of the number which is written after division. See, this number no need to make any changes, 1 by 3 as it is we have to write. So 1 by 3 division is changed to multiplication and 1 by 4 is changed to 4 by 1. So we can multiply now. 1 into 4 is 4, 3 into 1 is 3, whole square. Whole square or power 2 means this number will get multiplied by itself 2 times. 4 by 3 into 4 by 3, 4 into 4 16, 3 into 3 9. See, when we do multiplication of two fractions or multiplication of two rational numbers, numerator will get multiplied by numerator and denominator will get multiplied by denominator of the other number. So 3 into 3 9, 4 into 4 16. So when we were doing like addition, denominator we don't make any change, simply we write as it is. Now let's do the next part. Here in this part it's given to us 2 to the power 2 plus 3 to the power 2 multiplied by 1 by 2 whole power 2. See, bases are not same till now. First we have to solve again every time. First thing is that we have to see BODMAS, because we have to figure it out from where we have to start. So BODMAS is brackets we have to solve first. So we'll solve these brackets first. So here in this bracket if we see, the bases are different and moreover they are getting added. So we cannot use product or quotient rule here. We have to solve it. So 2 to the power 2 means 2 is getting multiplied by itself 2 times. Plus 3 to the power 2 means 3 is getting multiplied by itself 2 times. 3 into 3. So don't multiply with powers like 2 into 2 and 3 into 2. No. Exponent means that number is getting multiplied by itself, that number of time whatever is the power. So that's what we have done. 2 to the power 2 is 2 into 2 and 3 to the power 2 is 3 into 3 multiplied by 1 by 2 whole power square. So 2 into 2 is 4 plus as it is 3 into 3 is 9 into 1 by 2. Here itself we can change because we have to solve the bracket. So this also we can solve here itself. So 1 by 2, its power is 2. That means this will also get multiplied 2 times. 1 by 2 into 1 by 2 because its power is 2. So the number will get multiplied by itself 2 times. So 1 into 1 is 1, 2 into 2 is 4. 4 plus 9 is 13. So here we will not write anything, into 1 by 4. See here you can just write 1 so that you should know this is one fraction and this is one fraction. Easily you can do multiplication of two fractions. So 13 into 1 is 13 1 into 4 is 4. See why we are writing 1, because when we write 1, it doesn't make any difference. 13 is equals to 13 by 1. So just to remove confusions, we just write 13 as 13 by 1, so that easily we can do multiplication. So 13 into 1 is 13, 4 into 1 is 4. So the answer of this is 13 by 4. Now let's do the next part. So this part is very much similar to the previous part which we have done. So I want you guys to pause the video and try it yourself also. So once you're done, you can just relate the answer. Here also same rule we have to see. So B we have to do first. So B means brackets we have to solve. So let's start. If this bracket we see bases are different. Bases are different. So we have to solve it the way like we have done in the previous question. So 5 to the power 2 means 5 will get multiplied by itself 2 times. Minus 3 to the power 2 means 3 will get multiplied by itself 2 times. So 5 into 2 means 5 to the power 2 means 5 into 5, and 3 to the power 2 means 3 into 3. Here power is negative, we can make it positive by doing the reciprocal of the base. So base is 2 by 3, if we do its reciprocal, it will be changed to 3 by 2. Numerator will be changed to denominator, and denominator will be changed to numerator, and the power it will change from minus 3 to plus 3. 5 into 5 is 25, minus 3 into 3 is 9. Into this also we can solve. So 3 by 2 into to the power 3 means it will get multiplied by itself 3 times, which means we have to write it as 3 by 2 into 3 by 2 into 3 by 2. 25 minus 9. 25 minus 9 is 16. 16 into 3 by 2 into 3 by 2 into 3 by 2. See this 16, since we are doing exponents chapter, so everywhere whenever we can make any number or we can convert in any number into its exponential form, we can do that. So 16, let's find the exponential form of 16. 16 we have to make the factors. So like we make factors while calculating LCM. So 2 into 8, 2 into 4, 2 into 2 and 2 into 1. So factors of 16 is 2 4 times. See 2 into 2, 2 into 2, 2 into 2. So we can write 16 is equals to 2 to the power 4. So 2 is getting multiplied by itself 4 times. So 16 is 2 to the power 4. So here in place of 16, we can write 2 to the power 4 into 3 by 2 into 3 by 2 into 3 by 2. Two to the power 4 means 2 into 2 into 2 into 2. 4 times 2 is getting multiplied by itself into 3 into 2 into 3 into 2 into 3 into 2. So here with all the numbers you can write 1 to reduce confusions. To make this also fraction, easily we can solve. So 1 2 will get cancelled, second 2 will also get cancelled, and this one will also get cancelled. So what we are left with, 2 by 1 into 3 into 3 into 3, or 3 by 1 into 3 by 1 into 3 by 1, because all the 2's we are cancelled on 1 1. So this is what we are left with. So now we just have to do multiplication. So here 2 into 3, 6, 6 into 3, 18, and 18 is to 3, it is, we can multiply, it's 54. And there is, see, here we have done it by this, and there is another way also we can do. Here I will just explain you. So same answer we will get by either way if we do. If you are doing by this way, it's fine. See here we got 2 to the power, from here I am continuing. So here we got 2 to the power 4. into, see, if we don't change its exponential form here, we have 3 to the power 2 and 2 to the power 3 to the power 3 and 2 to the power 3. Because see, when this whole bracket is there, whole bracket means this power is with this also and this power is with this also. So 2 to the power 4 into 3 to the power 3 and 2 to the power 3. See, this 16 is just 2 to the power 4. This is getting multiplied by this. So here one easy way we can see, these two are in numerator, these two numbers are in denominator. So what we can do, and here we can follow quotient rule. See, 2 to the power 4 and 2 to the power 3, both the bases are same. Bases are same and they are getting divided. See, this is in numerator and this number is in denominator, means both of the bases they are getting divided. So if the numbers are same and they are getting divided, we can subtract the powers. Power is 4 and its power is 3. So 4 minus 3 into 3 to the power 3. 4 minus 3 is 1, 2 into 3 to the power 3. So if you multiply 2 into 3 to the power 3 means 3 into 3 into 3. So same answer 54 you will get. So here we have done without applying exponential rules. Here we can apply exponential rule also and we can solve it. Same answer we will get. Now let's do the next part. So in next question it's given 1 by 4 raised to power minus 3 minus 1 by 4 raised to power minus 3 divided by 1 by 6 whole power minus 3. It's 1 by 3. If we see this question, see, first of all here minus sign is there. So rules we cannot apply here. So board mass only we have to see. What we have to do is solve the brackets first. So this bracket will solve. First step what we can do, since it is subtraction, we can just make the powers positive because the powers are negative here. So how to make powers positive? Yes, we have to do the reciprocal of the bases. So here base is 1 by 4. If we do the reciprocal of 1 by 4, it will become 4 by 1. So 4 we can write, 1 in denominator, no need to write. And its power will be changed to plus 3 or simple 3 we can write. From minus 3 to 3 we have changed it. Same way we have to do this. 1 by 3. 1 by 3 to the power minus 3. Power is negative. In order to make it positive, we have to do the reciprocal of the base. So base is 1 by 3, reciprocal of 1 by 3 is 3 or 3 by 1 whole cube. Divided by this also we can make the power positive. Reciprocal of 1 by 6 is 6 by 1 or 6 we can write, and power will be changed from minus 3 to plus 3. So now in this step we have made all the powers positive by just doing the reciprocal of the given numbers. Here if we see minus is there, we cannot apply any of the rule, so directly we have to solve. 4 to the power 3 means 4 into 4 into 4. 4 is getting multiplied by itself 3 times. 3 to the power 3 means 3 is getting multiplied by itself 3 times. So 3 into 3 into 3. This I have just written expanded form because we cannot apply any rule here. So we just have to expand it and solve it. 6 to the power 3, it's 6 into 6 into 6. 4 into 4 is 64, 4 into 4 is 16, 16 into 4 is 64. We just can multiply here. 3 into 3 is 9, 9 into 3 is 27. Divided by 6 into 6 into 6, or we'll change it later. As of now we'll just write it 6 to the power 3, 6 to the power 3. Now we can just do the subtraction. 64 minus 27, it is 7. 37. 14 minus 7, 7, and 5 minus 2, 3. So it is 37. 37 divided by 6 to the power 3. See this division sign, what we can do? We can write it in this way. This is also division only. So instead of writing this sign, we can write this. And 6 to the power 3 here, we can write in this way. See what we have done. See whenever 1 divided by 2 is there, so we can simply write it 1 by 2. This division sign, we can replace it by this sign of a fraction. Same thing. This is also division, this is also division. So just this thing we have done here. 37 divided. So this division sign I have just changed it to a sign of this fraction. So it will be 37 upon 6 into 6, 36. 36 into 6 we can multiply. So it is 216. So this is the answer, 37 by 216. If you want, you can change these fractions into mixed fraction also. You can leave it here also. Now let's do the next part. In this part, it's given to us minus 3 by 4, its power minus 2, and then again whole power 2. Here the last rule, this power rule we have done. So when our base, it has two powers, one m and the other one n. So these can be any integers, positive or negative integers. When these powers will finish off this bracket and will multiply the powers m into n. Same thing, same rule we will apply here, because it's clearly visible two powers are there on a single base. See, the base should be single. Two powers are there on a single base, so we will apply power rule. Minus 3 by 4 we will write as it is, whole bracket minus 2 into 2. One power is minus 2 and the other one is 2. So according to power rule, when two powers are there on a single base, we just have to multiply the power. So I am just doing same thing, minus 2 into 2. Minus 3 by 4, we can multiply minus 2 into 2. It's minus 4, because 2 into 2 4, and only one minus sign. So as it is, that minus sign we have to write. Minus 3 by 4 whole power minus 4. Now here we can first make this power positive. So minus 3 by 4, if we do its reciprocal, see power, it can be changed from negative to positive by doing the reciprocal of a base. So if we do the reciprocal of minus 3 by 4, it will become 4 by minus 3. 4 by minus 3 whole power 4. Minus 4, it will be changed to plus 4 on doing the reciprocal. So now we just can solve it. So 4 by minus 3 raised to power 4, it will be changed to 4 by minus 3, 4 by minus 3, 4 by minus 3, 4 by minus 3. Number will get multiplied to itself 4 times, as 4 is the power. So we can multiply now. 4 into 4 16, again 4 into 4 16, and 16 this way also you can do. 4 into 4 16, 16 into 4 64, 64 into 4 we can do. This is 256, and 3 into 3 9, 9 into 3 27, 27 into 3 you multiply, it will be 81. Now what about this minus sign? See, two minus signs will get cancelled with each other, and two minus signs will get cancelled with each other, and our answer will be positive. So here our answer will be 256 by 81, positive. Here one thing you can understand, see, if I have any number, let us take any number minus 2, any negative number, because here negative number was there. If any number, any negative number has power positive, positive will say like 10, plus 10, positive even number. See, all the numbers like 2, 4, 6, 8 are even number. If the power is even number, this minus 2 you can write it as plus 2, because when the minus signs are of even times, they will get cancelled with each other and you will get positive number as your answer. But when the power is odd number, the answer will be negative. When the power is even, this negative number will give us positive answer. When the power is odd, odd means 1, 3, 7, 5, all those numbers, they are odd numbers which are not multiples of 2. If the power is odd number, then our answer, then negative number will give us negative answer. So this thing you can always remember. Now let's do the next part, which is exactly similar to this one. So this part exactly similar, as I have already told you, one single base and two powers are there. So same rule we have to apply, power rule. When single base it has two powers, we have to multiply the powers. Same thing we'll do here. So 3 by 5 is the base, minus 2 and minus 2. These two are the powers like m and n. So minus 2 we can multiply with minus 2. So 3 by 5 minus 2 into minus 2. So 2 into 2, 4. Minus and minus sign will get cancelled. So 2 minus signs, they will get cancelled with each other. So 3 by 5 whole power 4. So which means if we have to solve it, it will be 3 by 5 into 3 by 5 into 3 by 5 into 3 by 5. See, number will get multiplied by itself 4 times because the power is 4. Exponent is 4. So we can just multiply now. 3 into 3, 9, 9 into 3, 27, 27 into 3, 81. 5 into 5, 25, 25 into 5, 125, and 125 into 5, 625. You have to do the multiplication and then you can write the answer. Let's do the next part. In this part, it's given to us 5 to the power minus 1 into 3 to the power minus 1 whole bracket divided by 6 to the power minus 1. So again, first thing is we have to see which thing we have to do. See, division is also there and multiplication is also there, and this bracket is also there. See, if bracket is not there, when the thing is different, we have to just see between these two. But now the bracket is there, so that also we have to see. According to word mass, we have to do bracket first. So let's solve it. Bases are not same, they are different, but the powers are negative. So let's make the powers positive first. So 5, we can write both of these numbers in fraction form. So 5 we can write it as 5 by 1, 3 we can write as 3 by 1. So in order to make negative powers positive, we have to do reciprocal of a base. So 5 by 1 will be changed to 1 by 5, plus 1 no need to write because the number is 1 time, that means the power is 1 only, multiplied by 3 by 1, 3 by 1 raised to power minus 1. So in order to make the power positive, again we will do reciprocal, so it will be 1 by 3, plus 1 no need to write, divided by, here also in this step only we can make the power positive. So 6 by 1, if we do its reciprocal, it will be 1 by 6. So power is positive now. Here we can solve it. 1 into 1, 1, 5 into 3, 15, divided by 1 by 6. So when the two fractions are getting divided, so same first fraction we can write as it is, then this division we have to change into multiplication, and see the number which is written after the division sign, again we have to do its reciprocal. So 1 by 6 it will be changed to 6 by 1. Reciprocal, numerator will be changed to denominator and denominator will be changed to numerator. Now we can do any cancellation if it is possible. So on 3's table we can do 3 into 2 is 6, 3 into 5 is 15. Now we can multiply 2 into 1, 2, 5 into 1, 5. So 2 by 5 is the answer. Now let's do the second question of this exercise. In second question, it's given to us if 1125, it is equals to 3 to the power m and 5 to the power n. Find the values of m and n. See here, this is equal to this and we have to find the value of m and n. So very simple method. See, 1125 is equals to 3 to the power m into 5 to the power n. So something, if we see, because since we are doing the chapter exponents, so every time we, first thing which we have to do, to write any number into its exponential form. So let's write its exponential form. And here also, if you see, here also this thing is giving us a hint that this number is equals to 3 to the power m and 5 to the power n, and we just have to find these two. So let's make the factors and we will see what is the power of m and what is the power of n. So here we will write left hand side, because this is our left hand side and this is our right hand side. We have to compare both of this to calculate these values. So let's first find the exponential form of this number. Since number is ending with 5, so we can start with 5 only. So 5 into 2, 10. You have to divide it and then just see directly. If you can do, you can do it, but make sure you are dividing and writing each and every number correctly. 5 into 2, 10, then again 5 into 2, 10, 5 into 5, 25, 5 into 4 is 20, 5 into 5, 45, then 45 again with on 5's table it will go. 5 into 9 is 45, 3 into 3 and 3 into 1. So these are the factors. So we can write 1, 1, 2, 5, it is equals to 5 into 5 into 5 into 3 into 3. That's what we have just now found. So this number is equals to 5 into 5 into 5 into 3 into 3. So 5 3 times. Both of these numbers we can write in exponential form. So 5 to the power 3 and 3 to the power 2. Because 5 is getting multiplied 3 times and 3 is getting multiplied by itself 2 times. So this number, it is equals to this. Now let's compare this value with the right hand side. So 5 to the power 3 into 3 to the power 2, it is equals to this. 5 to the power n into 3 to the power m. I have just rearranged according to this. In multiplication we can do. So if we compare, which is telling me 5 to the power 3, it is equals to 5 to the power n. So if we compare these two, we can see our n is equals to 3, because bases are same. If the bases are same, then the powers will also be same. So 5 to the power 3 is equals to 5 to the power n, which means n is equals to 3. Same way we can find the value of m. So 3 to the power 2, 3 to the power 2 is equals to 3 to the power m. If bases are same, we can compare the powers. So therefore m is equals to 2. Now let's do the last question of this exercise. This is the last question of this exercise, and here we can see in this question it's given to us, find x if 9 into 3 to the power x, it's equal to 27 into 27 whole power 2x minus 3. See, here one base is not given to us. This side one base is there, this side two bases are there. So in this question what we'll do, we will calculate, we will solve left hand side and right hand side separately. See, this is our left hand side and this is our right hand side. So let's solve left hand side first, and afterwards we can compare, because this equality sign means this thing is equal to this. So left hand side I'll take 9 into 3x, 9 into 3x. Like I told you, we are doing exponents. So make sure whichever number you can convert into its exponential form, try to convert it. So 9 if we see, 9 is 3 into 3 is 9, 3 into 1 is 3. So exponential form I want to write, it is 3 into 3. 3 into 3 means 3 to the power 2. So here just in place of 9 we will write 3 to the power 2. 9 only we have written in its exponential form into 3x, 3 to the power x. Now we can see bases are same. Bases are same and they are getting, these numbers are getting multiplied. So product rule we will apply here, where bases are same and the numbers are getting multiplied, we can add the powers. So power of this 3 is 2 and this 3 is x. So both the powers we just have to add. 2 plus x. 2 and x. So we just have added, only one time we have to write that base. I have written it one time and we have added the powers. So left hand side it is equals to 3 to the power 2 plus x. Now let's solve this one. Right hand side. See, right hand side it is 27 to the power 2x minus 3. Here again 27 we will try to write into its exponential form, because 27, see, 3 is the smallest, like 3 it cannot be further reduced, but 27 you can see it has like more factors. So we will try to write this also in exponential form. So 3 into 9 is 27, 3 into 3 is 9 and 3 into 1 is 3. So 27, if we see, it is 3 into 3 into 3, 3 into 3 into 3. So 3 getting multiplied by itself 3 times. So we can write 27 as 3 to the power 3. So write it down, 3 to the power 3 only in place of 27. So in place of 27 I wrote this as it is I have to write. 2x minus 3. See, when the powers, they are of like more terms, more than one term, so we can just put in bracket. Now here we have to apply power rule. See, single base and two powers. If single base is there with two powers, we just have to multiply the powers according to power rule. So same thing we will do. See, this rule we have already applied in so many questions now. So we'll just multiply 3 into 2x minus 3. So since these are two terms, so this 3 will get multiplied with 2 also and with this 3 also. So it will be 3 into 2x, 3 into 2, 6, x as it is we will write. So 3 into 2, 6, x as it is. 3 into 3, this minus sign as it is we have to write. 3 into 3 is 9. So 6x minus 9 if we multiply these two powers. Simple multiplication of the powers we have done. This 3 I have multiplied by 2x minus 3. 3 into 2x is 6x, minus sign as it is, 3 into 3 is 9. So this 6x minus 9. Now if we see in question it's given to us. In our question it's given to us that our left hand side it is equal to right hand side. This sign of equality means both the sides are already equal. Now we have solved. This, we will just write. See, left hand side I have solved and I got the answer as 3 to the power 2 plus x. Right hand side also we have solved this. So it is 3 to the power 6x minus 9, and these two are already equal, and you can see here bases are equal. I told you if this sign of equality is there and the bases are equal, then that means powers will also be equal. So since we have to find the value of x, so we'll just compare the powers now, because bases they are already written as equal, and we can see also 3 is equals to 3, we know that. So now powers we can compare. So 2 plus x is equals to 6x minus 9. So you can write here, therefore because of this equality sign, bases will be equal to each other and the powers will also be equal to each other. So 2 plus x is equals to 6x minus 9. So now we can just, like equations we solve, same way like terms we can shift to one side. And so first of all we have to find it out which are the like terms. See, this x and this 6x, these are same, like means same terms, so these terms we will write all together. And 2 and 9, these are like terms, means same number, so these two we will write together. So let's shift this minus 9 to this side and x to this side. 2 I will write as it is, because side of 2 I am not changing. 2 minus 9, if I shift it to this side, minus 9, on changing the side it will be changed to plus 9. 6x is already there, side of 6x I am not changing, only x I am bringing to that side. So plus x, on changing the side it will be changed to minus x. Now 2 plus 9, 2 plus 9 is 11, and 6x minus x, see x only whenever it is written, that means it is 1x. So 6 minus 1 is 5, x as it is we can write. Now we only have to find the value of x, only this x, but here 5 is also written. See, when 5 is written with x, that means that 5 is getting multiplied by x. Since this number we have to shift into other side, so this multiplicative thing, that multiplicative term, on changing the side it will be changed to division. So x will be equals to 11 by 5. See here, plus will be changed to minus on changing the side, and minus will be changed to plus. Same way, multiplication will be changed to division, and division will be changed to multiplication on changing the side. So on solving we found the value of x as 11 by 5. So with this our exercise 2.a is completed, and next exercise 2b I will do in the next video. Thank you so much for watching the video. I will see you in my next one.